Hello, this is Collatz, and today I'm going to show you a proof that shows why all numbers go below themselves and show you why you only have the loop at 421. The first thing I want to do is show you this wheel. It's 18 steps out from the number 1, and the color coding we're going to use as we go through the slides. All numbers are going to be mod 8, and then 1, 3, 5, 7. So 1 will be yellow, 3 will be green, 5 will be blue, and 7 will be red. And what I want you to notice with the wheel is that almost all the numbers are blue. And that is because you cannot get to 1 unless you go through a mod 5. And so in my previous video I showed why all numbers divided by 2 will find an odd number, and when you multiply by 3, add 1, divide by 2, you will find an even number after 2 steps. Today I'm going to show why all numbers will fall below themselves in 3 steps from mod 5 and mod 1. And then all mod 8.3 numbers will go to the mod 5 or mod 1, and mod 7 will go to mod 3. Right, no odd number can get to 1 unless it's mod 5. And they're very particular, right? It has to be 101, and then we're going to add a 10 to the left of the 5. So 5 is the first number that can get to 1. 21 is the next. 58 would be 1010101, and 341, and so on. So we're just adding a 10 in front of 5 to find the next mod 5 that can get to 1. Right, and I'll also show you why we have the 421 loop. And we need to understand the question that's really being asked here, and that question is, can we divide an odd number in half? And the answer to the question is a yes. And we do that by multiplying by 3, adding 1, and then dividing by 2. And what this does is we take a number, right, a bit from, right, our right side of power, we subtract 1 from that, and then we multiply our left power by 3 and add the 1 back to it, right? And this gives us a number that we can now divide by 2, and our 1 bits on the right side will be 1 less. Well, it'll be 1 power less. Now the problem we run into with the loop is that you cannot divide a power 0 in half, right? So 1 by itself cannot be divided in half, because you have 1 on the right. We're going to subtract 1. We're going to multiply the left, which is 0, times 3 gives me 0, plus 1 gives me 1, but it's in the 4 slot at this point. So 1, when we divide 1 in half, we get 4. So it creates this loop because we're taking 1 from the right, subtracting it, and adding it to the left. But when we add it to the left, it's now shifted the power from the 2 slot to the 4 slot. And so it just creates a loop. And so again, when we divide 1 in half, the result is 4 because it cannot be divided. All right, and now I'm going to just go into more detail on why this is happening. And so I want to start with every number can be built from mod 8 and that number. We're going to take all the odd numbers and do this to them. We're going to take the mod plus 8 times x and get the results. So x is any whole number, and then m would be 1, 3, 5, or 7. And so what that looks like is this. So I take 8 times 1 is 8, and I add 1, I get 9. 2 times 8 is 16, add 1, I get 17, and so forth. All the way up to 10 times 80, or 10 times 8 is 80, plus 1 is 8. All right, and so I can do the same thing with 3, 5, and 7. And so any number that you can come up with, if it's odd, you can subtract 1. You mod it, find out the mod, subtract the mod from it, and then divide by 8. And I'll let you play with that on your own time. I was going to show you some more examples, but so here is where I say all mod 3s are going to be mod 5 or mod 1. So if we start with 3, 11, 19, 27, the end results in three steps, or 2 steps, is 5, 17, 29, 41, which is mod 5, mod 1, mod 5, mod 1. So we're just going to cycle back and forth through those. Mod 7 is going to cycle between 7 and 3, right? So we're covering 1, 3, 5, and 7 with all of these. So 3 holds on to 2 patterns, and 7 holds on to 2 patterns. And they alternate back and forth. 1 in 2 steps, in 3 steps. Sorry, I've added an extra step in here because to get to an odd number with the mod 1, you're not going to be back to an odd number until you're at 3 steps. So at 2 steps, it's going to alternate 2, 6, 2, 6, 2, 6, 2, 6. When we divide by 2 again, we get 1, 7, 5, 3, 1, 7, 5, 3, 1, 7, 5, 3. And so we can see, right, we can have all the different results for a mod 1. So an mod 1 can go back to another mod 1, it can go to a 7, it can go to 5 or a 3. And with mod 5, the only difference between 5 and 1 is that it's a bigger loop than a 4 to 1 loop. So what you have is in 3 steps, it's still going to be an even. Right, you have to go at least to step 4 to get back to an odd number. And then you can go to literally infinity on how many times you want to multiply by 2 above that. But at the third step, we're going to cycle through the 4 even mods. So 4206, 4206. And if I go look at the next set, right, I'm going to change the numbers that we're starting at, but you'll see nothing changes as far as the mods. So I've changed all the numbers. Nobody saw any number or colors change because the mods do not change. Right, so I can go to the next 4 sets of these numbers and nothing changes. Right, so what does that mean? So if I mod a 1357 number with mod 2, mod 4, mod 8, mod 16, what is happening? Right, at mod 2 I get the result mod 2 1 for all 4 of those numbers, right? 1, 3, 5, and 7 are going to give me mod 1, right? Because they're odd, and 2, 4, 6, 8 or 0, 2, 4, 6 are going to give you mod 0 or mod 2 0. So mod 4, 1, and 5 are going to be mod 4 1. And 3 and 7 will be mod 4 3. So now we're splitting those into 2 groups, right? And that's why you see 3 and 7 after 2 steps are right back to another odd number. And then with 1 and 5, they have to go 3 steps because of the way the bits are placed in the numbers, right? So with mod 8 and any mod above it, so mod 16, right? 1s are going to be mod 8 1, 3s are going to be mod 8 3, 5s are going to be mod 8 5, and 7s mod 8 7. Right? So what we see is that after the number 7, there's nothing new happening, right? All of our formulas are going to match the formulas that are established with 1, 3, 5, and 7. And so I can precisely calculate what's going to happen next to this number, right? And know nothing new is going to happen. They will all follow the same patterns. Right, and so again, how this plays out is you have a number. We're going to go start from the right, find the first one, and then from the first one we're going to search left for the first 0, and that is our power slot. So everything on the right is going to be we're just going to be subtracting, right, and adding numbers to it, right? And since we're dividing an odd number in half, we're just going to continually subtract a 1 from the right. And when we take a 1 from the right and move it to the left side, we're in the power, we're going to multiply by 3 and add 1 to the left side of the power. So whatever number I have on the left, I'm going to multiply by 3 and add 1. And on the right, I'm just going to subtract 1. Right? I'm going to get a 0 in the 2 to the power 0 slot. Right? I'm going to go from 1 to 0 there. And so that's going to allow me to divide by 2 and remove the 1 completely from the number. And so what does that look like? In the numbers we look at, right, I'm going to lay them out like this. We're going to look at the number, the binary. Marks are from a website. Mod 8, I'm going to look at what mod we're at to determine, what is going to happen next. it says mod 8, but it's the binary. The second mod 8 is the binary of the number. And then I'm going to count the bits left of the power slot, the right, the formula, and then I do a difference check to make sure the number and the formula results match. And so what that looks like is this 161, there's a binary. It's a mod 1 number, and then there's the binary colored. And so I color it to show where the power slot is and what's to the left and right. And the colors, right, colors on the left of the power slot are going to be orange for 0, green for 1, and the white means that when I multiply by 3 and add 1, when I'm at my last number on the right, which is giving me my mode. My mode is the last 3. The white is where the 1 is going to land with the single number 1 left. So it's telling me how many divide by 2s am I going to get. So I can look at the white and know how big of a power change am I going to have happen next. And so when I look at this number, the power slot is in 2. So to the right of it I have a 1. And then when we add up the numbers to the left of the power slot, I have 1 0 1 0 0 0. So the white is a 0. It's just colored white because it's in the last 3 spots. What the number does is it looks just something that I show in other videos is when you're looking from the right, when you're down to the last one, the first one is going to show up at the left of the first pair. So I color those white out. So if it's 1 0 1 0 1 0 1 0 0, those last 2 zeros are a pair. The one on the left will be where the first one lands in the new number. And I'll show you that here when we start digging into the 2 numbers that we're going to look at. But again, the explanation of it is the number is the number we're looking at. The binary is its code. The mod is what mod it is. It's going to be mod 1, 3, 5, or 7. The gray 0 is the power slot for that number. Right, everything to the left and right is its own number. Right, so the formula takes the 3 pieces of that and does this, right? It takes the power times the power slot times the left side number plus the right to get to the number 161. Right, so if I take 2 times 2 is 4. 4 times 40 is 160 plus 1 is 161. So the formula takes the 2 numbers and puts them back together and verifies that it matches the number that we're looking at. And so then I do a difference check to make sure, right, if I get something other than 0, something is wrong. Right, and so now we're going to look at your favorite number 27 and one of my favorite numbers 1023. But before we do that, I just want to cover a couple things that since my last video I've discovered, right? The formula, right, to understand what 3n plus 1 is really doing in 2 steps, right? This is the formula that you need to learn. N plus 1 divided by 2. So we're taking half of the number that we're at and adding it to itself to get 2 steps down the road. Now sometimes that'll be even, sometimes it'll be odd. But this takes a 1 from the right number and moves it into the power of the left number. Right, so you're removing 1 from the right and putting it in the left. And so one of the things that I just noticed when we run through this formula with the number 1 in 2 steps, we get to 2. There's a difference of 1 between those 2 numbers. The next odd number is 3. When we apply this formula, we get to 5. There's a difference of 2. The next 5 goes to 8, difference of 3. 7 goes to 11, there's a difference of 4. And then 5, 6, 7, 8, 9, 10, 11, 12, and so on. So every odd number, when we take this 2-step process, we get an increment to how big of a difference there is between them. Right, so 71 goes to 171, that's a difference of 36. So using this formula, right, and if you look at all the odd numbers, they're 1 less on the right of the power 0 than they were before. So one of the other things that I want to talk about is every number that's mod 5 or mod 1 will be below itself in 3 steps. And so we're going to look at these. If I take the number 5 in 3, right, multiply by 3, add 1, I'm at 16, divided by 2, I'm at 4. 53 goes to 160, 80, 40. So 53 is more than 40. So in 3 steps, I'm below where I started. 61 goes to 46. And you'll notice we're starting at a mod 5, so we're going to be even after 3 steps. So here's a mod 1, right, and it ends with a mod 5. Right, so with a mod 1 in 3 steps, I'm going to be odd again. And it's 325, which we know 325 is going to 0 or to 1 because the previous one did. And so here's the next step up. Right, 577 goes to 433. And so you see with mod 1, I can have a random result, right? I can have all 4 mods showing up as in 3 steps from a mod 1. Whereas with mod 5, I'm still going to be even, so I'm not going to be modding into an odd number. 3077 goes to 2308, so I know I'm going to 0. 2429, 1822. Here's another mod 1, it goes to mod 7. Another mod 1, it goes to mod 3. So with mod 1, I've hit all 4 now. 445 goes 340, mod 1 back to a mod 5, mod 1 back to a mod 7, mod 1, mod 7, mod 1, mod 3, mod 1, mod 1, right? So we're seeing this happen with mod 1, I can have all 4. And with mod 5, I just not going to see it in 3 steps. right? I have to use a different formula to know how many steps it's going to take to get back to the odd. Now, the peculiar thing about all of these numbers is they're all in the number 27. So all of these mod 5, mod 1 numbers, right, which are mod 1s are just a 4-2-1 loop into the next odd number, right, which is what you have with 4-2-1. 4-2-1 just repeats itself. Now with mod 5, they're just bigger loops, right? So we're going to take longer to get back to 1. And so now let's look at one of my favorite numbers, 1023. So 1023, we're starting with a power in the 11th slot. And so all of our 1s are on the right side. So we add those all up and we get 1023, which means we have 0 to the left. So when I multiply 3 and add 1, I get to 370. And if you look, I've subtracted 1 from the right side, and I've multiplied my left by 3 and added 1. So 0 times 3 plus 1 is 1. So I've subtracted from the right, I've multiplied by 3 and add 1 to the left. So when I now, right, I'm at an even number, I'm going to divide by 2. So we've shifted, when we divide by 2, we take our power slot and we've moved it to the 10 slot. Right? And I've literally cut 1023 in half. But I did that by taking a 1 bit and moving it to the left side of the power. So now I'm going to do the same thing again. I'm going to multiply by 3, add 1. And so now, right, we've subtracted 1 from our right side. And I take 1 times 3 is 3 plus 1 is 4. So if you look at our binary code, we have 100 in the left and we have 1050 on the right. Divide by 2, I take 511 and I've divided it in half. Right, my power is now at 9 and I have a 4 on the left. I do the same process again. I subtract 1 from the right, multiply 4 by 3, I get 12 plus the 1, and I get 13. So 1101 on the left and 7 1s on the right. So I divide by 2, lower my power to 8, and I've taken 255 and divided it in half. Do the same, repeat the process. 13 times 3 is 39, plus 1 is 40. Divide by 2, I've divided 3455 in half and got 518. And if you look, our numbers are staying in higher numbers. All right, so when we do our checks, right, our formulas are giving us the same numbers, but our right side is dividing in half the odd numbers. But we're multiplying by 3 and adding 1 to the left side, right? We're not changing any structure on the right except subtracting 1 from it. So I subtract 1, and then I can divide an odd number in half. 63 goes to 31. 31 goes to 15. Now 15 is going to go to 7, right? 7 means I'm at a true mode 7. So that means in 2 steps I'll be at a mod 3. Right, and 40 times 3 is 120, plus 1 is 121, 364, 1093. And so we do this again, and we go to mod 3. And we take 7 and divide it by 2 and get 3. We do this process again, and we're going to get mod 5 or mod 1. And in this case, it's 0, 1, 1. So we're going to get a mod 5. And so you can see here I've whited 1, 0, 1, 0, 0 from right to left. So I'm going to do a 16, right, a divide by 0 4 times to get back to the next odd number. So now if you look, we've taken 0 from the left and 1023 on the right, and we've shifted it to 9841 on the left and 1 on the right. Now when we have 1 on the right, we're resetting, right? We're going to take the last one from the right and throw it to the left, and then divide down till we get 1, till we get to our next odd number. And then we're going to repeat this same process. So in this case, see, we went to 16 and 1848. So we shifted the power out to, right, we went out to 1 at the 16 slot, so we have the power slot in slot 6. So we take everything to the left, and that's 1845, and we have 16 on the right. So now we're going to divide by 2, and since we're even numbers, right, we're going to go 16, 8, 4, and so here in 3 slots, right, we now have dropped below where we were, 39, 365, and in 3 steps we're now below that number. So at this point I can know for certain that I'm going to go to the 421 loop. Right, and here we have 421 loop, right? So now look, this number is going to go out to 1, 2, 3, 4, 5, 6, 7, 8 to the 9 for the power. Right? So here's the number what we're at, and then we're going to go from a 2 power to 9. So I go from 1 to 128. And we're at 43 on the left. And so, right, we're just going to divide by 2. So all we're doing is cutting our right side in half because we're taking zeros. We're just doing divide by 2, and the left side is staying the same all the way down till we get to the 1. Right, so now I have 43 on the left and 1 on the right. When I have 1 on the right, I'm going to do my power shift. And in this case, I'm going to go out to 8. Right, so there we are. We have 16 on the left and 8 on the right, and the power shifted from 2 to 5. And so I'm going to divide by 2 3 times, right? And I'm back to 1. And you can see here the green in the left are numbers that are below, right? 3 steps, we're below an odd number that we were 3 steps prior. And so 173 drops to 130 in 3 steps. And so now we're at 1, we're actually in a mode 1, so I know in 3 steps, alright, I'm just going to do a 4 to 1 loop here. And so here we go, 4 2 1 loop, right here, and we know 65 is more than 49. And we're at another mod 1. Right, and we actually, the glide, that number, right, we started at 1023, so we've actually proved that 1023 goes to 421 because we've hit a number below it at the glide. And so the maximum was the highest it climbed. I don't know if you all saw, it said maximum in the remarks earlier. But now we're at 49, and I know in 3 steps I'm going to be below 49. And I'm going to do a 4 2 1 loop again. And now I'm at a mod 5 at 37. So I'm going to do a C8 4 2 1 loop. But in this case, we have an interesting thing. We have 3 1s tied together, right? So we went from 9 to this 3 1s together. So we basically took our 3 1s and merged them together. So we went from 9 on the left to 0 on the left and 112 on the right. But we're going to half it 4 times, right? And 73 is below 128. And we're going to divide by 2 more times, and we hit a true mod 7. So with the true mod 7, I'm going to be at mod 3 in 2 steps, right? So I have 0 on the left, 7 on the right. So now I'm going to go to 1 on the left and 6 on the right. And so here we see again, we're going to climb 3 times. So we're going to go 1, and then 1 times 3 plus 1 is 4, and then 4 times 3 is 12, 13. So we're going to go through these. The left numbers are going to be 1, 4, 13. And the numbers on the right are going to go 7, 6, 3, 2, 1. So on the right, we're going to go down till we get to 1, and then we're going to do a power shift, right? We're going to move the power out, right? In this case, we're going to go out to 4 2 1 loop, right? And it's 52 or 17, so we're going to be at 13 with mod 5. Mod 5 is going to go to 5. And then we're going to do our last power shift to, so here, right, if you look at the bits, we've had multiple numbers of bits, but with the number 5, when we do our power shift, we shift to 6 with 1 on the right and nothing on the left. So that's going to take us to, right, we went from 5 to 4 to 1. So we did our 4 2 1 loop, and so now I'm at 0 on the left, 1 on the right, and a power of 2. Now, when I subtract 1 from the right side, I'm going to be at 0, and I'm going to multiply 0 times 3 plus 1, and I'm going to get 1. So I'm going to move my 1 over 2 slots to the number 4 slot. But what happens is, right, this shouldn't be the results, right? When I can't, the formula doesn't know how to handle the number 1 because it's taking 1 from the right, moving it to the power on the left, but at the same time it shifts the power past the 1 that we're at, because I have to have 1 on the right. And so that puts me back at 0 on the left, power of 4, and a 4 on the right. And then I'm going to divide by 2, get to 2, and 1. And so now I'm just going to continue to loop, because the 1 can't be divided any further. And so we have this loop happening because when we move our 1 from the right to the left, the power moves to the left with it. And so we can never get rid of the 1. And so now we'll take the 27. So 27 is a binary of 3 on the left, 3 on the right, and a power at 3. And right, we're mode 3. We're also mode 3 0, which means this is a number that we can't get to unless we start at it. But it's mod 3, so that means in 2 steps I'm going to be at 5, a mod 5 or mod 1, and so in 5 steps I'm going to be below step 2, right? So I take this number, I have 3 on the left, so I multiply by 3, I get 9, and so I'm going to be at 10 on the left, yes. And right, I take 3, subtract 1, and I move it to the left and get 10. I divide 3 by 1, or 3 in half, and I get 1. And so I'm mod 1, so I know in 3 steps I'm going to be at an odd number that's less than 41. Right, so 1, 2, 3. Right, and you see that our 4-2-1 loop, right, should have been 4-2-1, but we have a 5-bit number combined together. Right, so I'm doing a 5 times loop. Right, so I loop into this mod 7. So now I'm going to be mod 7 for 2 times. So, right, but 41 goes to 31, so I know I'm going to go to 0, right? And here's 1, 2, so I'm at 7, right, on the right side, so I'm at a true mod 7, so now I'm going to go to mod 3, right, and it went to 13 on the left, 6, I divide 7 by 2, or in half, and I get 3. I divide 3 in half, and I get 1. And so I'm at a 1 on the right, and I'm going to do a 4-2-1 loop, and I'm back to another 1. All right, and if you look, as we're doing these loops, my power is dropping, but my left number stays the same because we're just dividing by 2. So as we do these loops for the mod 5 and mod 1s, our number on the left side, the power number, is going to stay the same till we get to 1. And then we're going to reset the number, and we're going to do the 4 to 1 loop reset, right? So in here, right, we have 2 1s together, so we're going to do a 12, 16, 3, and then to 1, or it goes to 3. 3 is going to be a mod, or it goes to the number 91, which is less than 121. But because it's not just 1 bit, it went to 11, or 3 on the right and 11 on the left. And so now I'm going to go to mod 5 or 1. So I went to a 1, and it's right. So you can see on my right side, I'm just taking the number that I have on the right side of the power, and I'm just cutting it down till I get to 1. When I get to 1, I do a reset, and then divide down till I get to an odd number again, and then I divide by 1. Right, I divide my odd numbers in half using this formula. Right, so I took 137, divided it, or cut it down to 103 in 3 steps, but I'm at a true mod 7. So in 2 steps, I'll be back to a mod 3. And so we're at 155. Now I'm going to go to a mod 5, mod 1. And so I went to a mod 1. So in 3 steps, 233 will be below. Right, in 3 steps, I'll be below 233. And I'm at 175. Now I'm at a mod 7. That's not true. So now I'm going to cut it in half to 7. Right, so now I'm at a true 7. So now I'm going to go to mod 3. Now to mod 1. And then we're going to be 593. I'm at 445. Alright, I'm at a mod 5. So in 3 steps, I'm going to be at an even number. Right, so 56, 28, 14. And because of this, I know my next one's going to be a mod 7. Right, because I'm going to have 7 on the right and 10 on the left. Right, but my powers are dropping and I'm cutting the number in half. Right, so with even, right, my power drops every step. With odd numbers, as I'm going through them, my power only drops every other one.
Grocery time.
7 is a true 7, 167. I go to 251. So in 3 steps, I will be at So now I'm at mod 1. So in 3 steps I will be below 377. 1, 2, 3. Uh, 283. In 2 steps I will be at mod 1, 1, 2, 3. And because I'm not doing 4 to 1 loop, I'm doing this 252, 126, 63, right? I know I'm at this 319, right? The 319 is actually less than 425. But now I'm going to do a climb of 6 cycles, right? 3 of which will be a continued mod 7. So there's 1, 2, 3 mod 7s, right? So now I'm at the right side is a true 7. So now I know I'm going to go to a mod 3. And in 2 steps I'm at a mod 5. And I have a 1 on the right and have 429 on the left. And I know in 3 steps I will be below 2429. 2, 3, and I'm at 1822. Now I'm about to divide by 2 and get to 15, which is a mod 7. Alright, so I'm going to go up one more step. Well, I'm going to go up 4 times because I have 4 ones. But I'm going to go up 1 to a true 7. So I subtract 1 from 15, I get to 14. Divide by 2, I'm at true 7. So I know my next odd number is going to be mod 3. And so it's 2051. I multiply by 3, add 1. I'm at 6154. And I go to mod 5, 3077. So I know in 3 steps I will be less than 3077. But my next multiple, right, I'm going to multiply by 3, add 1. I'm going to be at my maximum number, 9232, right? But I'm at a 16, so I'm about to do a 4 divides. So 144, 144, 144, right? I'm below 3077 in 3 steps. 16, 8, 4, 2, 1. So I've cut down to a mod 1. So I'm going to do a 4 to 1 loop. I'm at 1 again, so I'm going to do a 4 to 1 loop. I'm at mod 5, so I'm going to do a bigger loop. 16, 8, 4, 2, 1. I'm at mod 5, so I'm going to do a loop, 8 loop, so 8, 4, 2, 1. I'm at 3, 1, so, right, and here, right, we've hit the glide, which means I started at 27 and I'm below it now. But we know all along the way that we're going to go to 421 because we keep hitting these odd numbers that in 3 steps are less than what they're at. But here I'm at a true 7, so I'm going to go 2 steps to a mod 3, 35, and then to a mod 5, 53, 53 goes to 5, I believe. Yep. Right, it's this huge loop. Right, 32, 16, 8, 4, 2, 1. And I'm at 5, so I know I'm going to go to 16, 8, 4, 2, 1. And then I've hit 1, and as you can see, my last 5 steps I have 1 bit. Right, and so I take the 1 bit, I shift it, the power shifts with it, and it stays 0 on the left. And so I just loop back to 1 again. So there is no other loops that we're going to discover because we're just taking 1 bit off the end and multiplying it by 3, adding 1 to the left side of the power. Right, so again, what that looks like is we start at 4, 2, 1, 4, 2, 1, 4, 2, 1. Right, we're just, and nothing is changing on the bits or the left side of the number, right? We're just shifting the powers around, and when we throw it out, right, we multiply 3, add 1, the power is shifting with it, right? So 1 is the only odd number that we have that's made up of just one bit, right? There is no other odd number that you can create that only has one bit. All the other numbers that, right, every other number requires 2 bits, unless it's a power of 2, right? And 3n plus 1's task is to remove a power of 2 from the right and move it to the left, right? When this process is done to the number 1, the power moves from the slot 2 to the slot 4 and moves you back to the number 4 being on the right side. And this is because the left is a perfect square, right? Perfect squares are 1-bit numbers that have nothing on the left. So 2, 4, 8, 16, 32. Right, the only other, right, perfect odd numbers are, and their squares are the only ones that have a 0 left number. So 1, 3, 7, 5, 31, 63 all have a 0 left, but they have multiple ones on the right other than the number 1. So all mod 1s will fall below themselves in 3 steps, right? They are the true 4-2-1 loops. So they start at 0, 0, 1 in binary, move to 1, 0, 0, 1, 0, 1, and back to 0, 0, 1. Right? The number 1 is the only exception because it never has, you can never have a left bit. The next one, 9, is 1, 0, 0, 1. Right, all mod 5s follow the same pattern as 1, just a few steps behind it, right? So 1 goes to 4 in 1 step, 5 goes to 4 in 3 steps. 3 goes to 10 in 1 step, 13 goes to 10 in 3 steps. 15 goes to 16, 31 gets there in 3 steps. So you have all these mod 5s that get to the same place a mod 1 does, just takes a few more steps. So every one has a 5 partner behind them. All mod 3s get to a lower number in 5 steps, but it will not be lower than a self. It will be, step 5 will be lower than step 2. Example 11 climbs 2 steps to 17, 17 falls to 13 in 3 steps. Right, this will be the pattern for all mod 3s. Mod 7s, right, all true mod 7s, meaning it's 0, 1, 1, 1 at the end of the binary, will add 2 steps to mod 3. So to reach the same spot. And for every bit past that, right, so if you have 15, which is 1, 1, 1, 1, you're going to add 2 more steps to that, right? And so 53 gets you to 40 in 3 steps, which is below it. 35 gets you to 40 in 5 steps. 23, 7 steps. 15, 9 steps. Right, and just so you can visually see this again, right? The only way to get to number 1 is through a mod 5. And all those mod 5s are going to be 5 plus 2 on the right. It's going to be 1 0 1 0 1 is 21, 1 0 1 0 1 0 1 is 85, and I'm just going to add a 1 0 to the left to get to 341, and do it again for 1365, 554, 61, and so forth. Right, so all of those are the ones that can get you to the number 1. Right, they have to follow that pattern. Everything else will be beyond those patterns. Right, and the websites I use for this, right, for if you want to play with numbers up to over 2 to the power of 200 and it has a binary, you can go to this website and you can see the steps, and it's the one that gives you the maximum number, the glide, and then the end. And for the wheel graph, I went to this website to pull that. What it comes down to is the number 1 is the only 1-bit number. You can't divide it from itself, and so the power slot shifts and you just keep repeating a 4-to-1 loop. So what this conjecture, what he's trying to do with 3n plus 1 dividing by 2 is divide the odd numbers in half on the right side of the power. Right, and this is the way to do that. And so he discovered that it kept looping at the 4-to-1, and it's simply because you can't divide 1 in half. Thank you for watching the video.